Greetings and welcome to the Daily Space Weather. We'll be doing things like looking at the sun in depth and not spouting a bunch of nonsense on the channel. Here's the sun in 304 angstroms ionized helium. And you can see some activity there up in your upper left, the solar northeastern limb. 0 sunspots. There are some filaments. Solar activity ultimately quite low. Here's more. Here's another view from the Solar Dynamics Observatory. This is 193 angstroms. Coronal hole up here. Some more coronal holes over here south of this active region are rotating in. We'll show you that a little later in the video. And here's a composite view close-up of that active region. This is actually two wavelengths, 171 and 304 angstroms. Portions of the ultraviolet electromagnetic radiation spectrum. Fantastic view of that. We've got an even closer one at the end of the video, so stay tuned for that. Here's a star chart. We've drawn in the ecliptic, and the sun has just risen at our location, which is Lehigh Valley, Pennsylvania. Jupiter about to set. Saturn has already done so. That yellow line is the ecliptic. Here's a diagram of the solar system. We hope you slept well during new moon. Let us know if you are a reverse werewolf or you get mysteriously less hairy and you sleep through the night instead of staying awake and going out and eating people. We'll advance this 1 week, as we like our viewers to be oriented to reality. The 10.7 centimeter radial flux down to 73. And the most proportional data set to sunspot number is the 10.7 centimeter radial flux. Here it is, this black line. That's a 1-year chart. Sunspot number all the way down to 0. That's the red line. Below it, that's from Solon.info if you want to look at that chart yourself. Here's a space weather enthusiast dashboard. And no forecast for any geomagnetic unrest or anything like that. Very weak solar activity here as solar cycle 25 sputters into its ramp-up. Here's a 90-day chart of global seismicity. You can find this one at volcanodiscovery.com. That's a 90-day chart, a bar graph. And we saw a bunch of activity here in the past 24 hours along the American Pacific West Coast there. A whole bunch of quakes all lining up in a pattern all the way from Siberia to Chile. So an interesting pattern there. The rest of the world quite low on quakes. That area fairly high on quakes, including some in the middle of the U.S. here, such as this 3.5 near Wheeler, Texas, and this 3.5 near Esben, Kansas. One of the largest quakes with a 5.3 was a 5.3 near the southern Mid-Atlantic Ridge. So no major quakes, some in the 5 magnitude range, low 5 magnitude range. Small deep quake near Timor-Leste at a 4.6 magnitude, 131.9 kilometers estimated depth. It's an earthquake lull. And we've been seeing a volcanic uptick. Let's see if it continues. Karimsky, flight level 040. It's producing a 4,000-foot volcanic ash plume over the Kamchatka Peninsula. Also Shiveluch, 13,000-foot ash plume produced over the Kamchatka Peninsula by it as it explodes. Suwanosejima exploding, or at least erupting. 8,000-foot ash plume over the Ryukyu Islands. And over the lesser Sunda Islands, a 9,000-foot ash plume produced by explosive activity from Luotolo. Mount Merapi, producing a 10,000-foot ash plume through explosive activity over central Java. smAsho continuing to erupt here as it explodes. 8,000-foot ash plume over the Aleutian Islands from smAsho. Fuego exploding over Guatemala. 15,000-foot ash plume there. Nevado del Ruiz. 19,000-foot ash plume as it explodes, producing a flight level of 190 over Colombia. Revenador exploding, flight level 160. It's a 16,000-foot ash plume over Ecuador. Sabancaya exploding, 24,000-foot ash plume over Peru and Nevados de Chilean. Intermittent emissions and explosions are enough to produce a 14,000-foot plume of volcanic ash. And no matter how bad things get, folks, please do not pole vault the caldera. It could be unhealthful. So this public service message brought to you at massive personal risk and expense by SMASH staff and I, the SMASH team, here at smashamash.com. Please visit the links and support the channel. Going back to sun-facing instruments here on the GHOST 16 to see no significant flares over the past 48 hours. There was a C-class flare from that active region, which briefly did have a sunspot right around 0 dark 100, 0 dark 0 on the 9th. We don't expect any major flares either because there are no sunspots. No spikes in the proton flux and no surprises to our channel. We would have forecasted a coronal mass ejection. We didn't see any. Actually, there was a weak coronal mass ejection. We'll get to it in a minute. GOES magnetometer here over the past 3 days. The Earth having moved into a North Pole-oriented current sheet. And here's the view of that, the top view ecliptic plane field plot. We've got fairly current data here. The Earth is solidly on a North Pole current sheet shown in green. Here's the last image, and you can see this green North Pole current sheet right here. We'll be in that for the foreseeable future. South Pole current sheet shown here in red. And here's a line of sight ecliptic plane field plot. Showing a three-dimensional view of the heliospheric current sheet's polarity. And here's our coronal hole plot, and you can see some North Pole-oriented coronal holes here stretching down beyond the equator. So we've got another trans-equatorial coronal hole. Those are the most geo-effective type of coronal holes. So if that remains intact, we can expect to see some solar wind, maybe some geoactivity produced from the induction of those incoming solar protons. So here we've brought up the flare probability monitor, and likelihood of major flares is pretty much nothing with 0 sunspots, and a prime example of how we don't need to see sunspots or solar flares to produce coronal mass ejection. So if you look out here on the western edge of the coronagraph here, you can see that there is some ejecta there. Nowhere near Earth, it's headed way out to the west. So far to the west, I don't even think it shows up on stereo A, but in any case, that's the LASCO C3 imagery. Next, looking at global geomagnetism, here is the KP index. KP of 2, geomagnetic chill conditions. Next, a real-time solar wind. And it looks like there's another coronal hole wind stream striking here as we saw the density go up and then come back down. And as the density came down, the velocity went up, an indication of another coronal hole wind stream. So we'll be seeing where this one takes us. Current solar wind conditions are 435 kilometers per second for the velocity, density just under 6 protons per cubic centimeter. BTBZ has recently shifted. We've got fairly equal magnetism from both poles here when we see a BZ of 0. I like the way it says -0. So we'll be watching that coronal hole wind stream today. Next, looking at magnetohydrodynamic pressure. And we don't expect that coronal hole wind stream to be very strong, as there haven't been very well-defined coronal holes facing Earth recently. So here's 4 hours of data, magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework. Fairly homogeneous here over the past 4 hours. Nothing too exciting to report there. Ground magnetic perturbations, we show it daily. And let me just correct myself once again. I've been saying that there are 2 north poles. There really aren't 2 north geomagnetic poles, folks. It's just that there is some some weakness and some funk in the northern hemisphere. The North Pole region is a little weaker than the South Pole region, and anyway, watch our video entitled Geomagnetic Mayhem, featuring Eugene the Philosopher, and make sure you subscribe to Eugene the Philosopher's channel. Shout out to Mr. Bagashov. We're delighted that you still are not in a gulag. Anyway, geomagnetic ground magnetic perturbations here, changes in the Earth's B field, geospace, delta B, whatever you want to call it, fairly uneventful. By the way, congratulations on realizing our channel exists. Thanks for tuning in, everybody. Thank you, viewers. We wouldn't be doing it without you, most likely. So, yeah, press like and subscribe. Tell your friends and foes about the content. Don't forget to Mensa. Yeah, don't forget to Mensa. Make Earth not suck again. Help us out by pressing like and subscribe. Press share. Tell your friends and foes and science noobs and science pros about the channel. We try to put something for everybody. Check out our old videos also. We've got thousands of videos. Check them out. And also more exclusive content coming soon on BitChute. Thanks to our BitChute subscribers. And to our Twitch followers. Help us get to 100 followers if you're not a Twitch follower. We only need 3 people to follow us on Twitch to get to 100. It's not really a significant milestone, but we do stream regularly live to Twitch. We'll be doing it again today for our cosmology and meteorology segments. And just so you know, today's cosmology segment will be a separate video. Make sure you check it out. It'll be airing after the daily space weather video. Let's get back to the Earth environment here. Looking at electrons, we don't see any charging hazards. As the electrons surrounding the planet can charge satellites, they aren't currently doing so. Here's a 1-year chart of this. That's also from Solon.info. Solon.info/solar. Here's a 3-day chart of the electron flux, and we can expect this to rise here once the current coronal hole wind stream subsides. Give it about 24 to 36 hours, and we should see a pretty big spike in the electron flux here. Keep in mind this is measured at the F ionosphere layer at about 300 kilometers of altitude by the GOES 16. Here's the forecast. And, you know, NOAA pretty much agrees with us here. No argument there on the forecast model. Here's a visualization right after we show you the Van Allen belts. There are the Van Allen belts. And distances shown in miles here. And here's an animation of the total electron content. This will give you an idea where GPS errors are most likely to occur. We've noted some major anomalies in this data set in the past week or so, actually. Past 2 weeks, I'll say. Everything looking fairly organized at the moment. Don't be surprised to see some additional anomalies if you follow this, as we see anomalies during coronal hole wind streams on the regs. Here's another diagram of the atmosphere showing you distances in kilometers. The relevant portion here is the F ionosphere layer, because that's what we're showing next. Here's the ionogram from Australian Government Bureau of Meteorology. And we see most anomalies associated with the South Atlantic anomaly, which is now over the South American continent instead of over the South Atlantic. And things are looking fairly normal here, as normal as they'll get with that anomaly over South America. So anyway, here's the latest image from 10:30 Universal Time. Things looking not so out of the ordinary then. Here's the anomaly, and this is the departure from 30-day median in megahertz. So we do see some anomalies here on both sides of the equator, actually, as well as some over northern North America. Anyway, I can't really explain a bunch of blobs of color on the screen. I'll just bring up the latest image. And there's the current anomaly situation. Some slightly higher than 30-day median charge-ups here, high vibration zones. And what you're looking at there is vibrational frequency in megahertz, millions of vibrations per second. We're going to do a meteorology segment today as well. Make sure you check that out if you haven't seen it. It aired before the daily space weather video. And we did a meteorology segment. If you're only watching the daily space weather video, check out our meteorology segment. There's some climate stuff in there. Here come bonus features like El Teide, Spain's ground-based solar observatory. So we've got some filaments. We may actually be seeing a coronal mass ejection happening here. It looks like that certainly looks like it may have ejected up there. Let's take a look at that on the stereo A. And indeed, I think that is a coronal mass ejection. You can actually see it just making it out from behind the back of the obscurement disk on the stereo A Core 2 coronagraph there. So that's something else we'll be keeping an eye on. We'll probably make a second video about that, a daily space weather supplemental. Make sure you come back to the channel later in the day today, as we've captured a coronal mass ejection as it occurs. Is it luck, skill, talent, training, or divine providence? Leave us a comment. Let us know. Let us know what you think. Here's the NASA GO 16 SUVI imagery. There is a crown prominence you'll see down here. We posted a screenshot of it on the Discord channel. Again, you can find all of our links at smAsho.com. smAsho.org will redirect you. Please support the channel by supporting our efforts via merch or becoming a patron or what have you. Here's a full disk image to show you 0 sunspots. Here's the magnetic environment. Again, 0 sunspots, a couple areas of magnetic organization there. Weak solar activity in general. And we'll close out the video with some more images of the closest star here. Here's the full disk 171 angstroms view. And you can see some plasma reorganizing itself right over here. Excuse me. And here's a composite. And for our regular viewers, you've probably seen 304 and 171 angstroms before, as we used to regularly fade to this. I think this is one of the best composite images we can get. It shows different features in the same view. Fantastic imagery. And here's the extreme close-up of this active region. And that's where we close things out. Thanks for tuning in. Remember, stare at the sun, attempt to understand the physics. Don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo Renaissance. May that solar wind be at your back.